To introduce Erika Cardenas from Weaviate, who's going to be leading our Women of Search session. And in the best traditions of Women of Search, being a man, I shall now get out of the way.
All right. I hope everyone's doing well. Oh, that's a bit loud. Or this way, away from my face. Okay, like this. Good. All right. I hope everyone is full from lunch and is doing well. Awesome. So the first talk that I'm going to give is an update on the Women of Search group. And my name is Erika Cardenas, but I'll get into my talk later on and then share a little bit about me in a few slides. So the Women of Search group is for women and allies, and it was started by Atita and Audrey. They created it a year ago, and on the Slack channel there are 150 women so far in the group, which is very impressive. And it's been really nice to be a part of their team. Sorry, I think there's a delay. So it's a non-judgmental place to bring cool ideas, questions, or brag. So if someone has a new position or is looking for jobs, this is kind of the space where we can share that with each other and also maybe ask career advice or questions that we might have. And then we also practice our public speaking and have sessions to help our soft skills. So we had a workshop with Sebastian from Weaviate, my boss. He had like an Ask Me Anything kind of session where he could kind of help us with public speaking and developing our soft skills. Last year we had Haystack EU 2022. This group covered how to create inclusive environments. Also, they covered the what are the desires for employers when job seeking, so kind of things to focus on. And then in the middle, we have the group from the EU session that was last year. So they presented the survey results identifying how women feel in the search community. And this is my first event at this conference, and I feel very welcomed here, and I'm very happy to be here. And then they also invited speakers to celebrate their achievements in search. Lastly, in Poland this year, they also presented vectors in e-commerce search and then how to grow the Women of Search group in Poland. So right now, we have a happy hour. If you're on the East Coast or in the United States in general, 12 p.m. isn't really happy hour, it's more so lunch. So maybe have like a Diet Coke or something with your lunch and join the group just to ask questions, brag, and I don't know, vent to each other. We tend to do that a lot. And we also host workshops, and cool sessions are planned for the future. So on the right, Audrey shared Sebastian joined, and he helped us with our public speaking. So we just asked him various questions. I know Megan is here, and she also joined, and we both enjoyed the session. And this was kind of my gateway into the group. I didn't know it existed before, so I really benefited from it, and I'm happy I am now a part of the group, and I hope to see more women join. And I also forgot to mention, I hope we can take a similar picture like this today. So for women and allies, if you wouldn't mind after the talk joining me for a group picture. You can join us on Slack. So this is the link. Kind of weird if you want to take a picture of it, or you could just go to the Relevance Slack, and then we have a Women of Search channel within that. So that is probably the best way to join. So I hope to see a few more faces in there. And Atita and Aurora, her last name is Aurora, but I always say her full name. Atita and Audrey and myself and Megan, everyone else will welcome you with full hands. Do you have any questions about the Women of Search group? Any comments? What? Oh yeah, that's right. Yeah.
Do we have any questions? I think you've obviously explained it perfectly. So
Thank you.
And there's nothing on the online. So
Okay.
Wonderful.
All right, well, thank you for that. Now I'm covering how to build recommendation systems with vector search. So a little bit about me for the 1,000,000th time. I think I've had my name on each slide so far. I'm Erika Cardenas. I'm a developer advocate at Weaviate, and I am new to the industry of search. I have a master's degree in economics and data science, so I'm new to this field, and I'm honored to be here with all of you and giving this talk today. I really like GIFs, so I hope this will play. feel like, oh no. 1 second. There we go. You are all search experts. You are familiar with this domain, and we've seen a lot of opportunities for searching through documentation, Slack, products. I mean, basically everything. You can even search through emojis at this point, and you are all familiar with this. But what about the concept of recommendation? They are a bit different on how this is done, and that's really what I'll be covering today. So sometimes it feels like these companies are kind of reading our minds. You go on Amazon and you're like, what the heck? How did they know I wanted this product? Their personalization is very good. And along with social media companies like TikTok and Twitter and Reddit, it's personalized each time you open up your home feed. This is a bit busy, so I hope it's not making anyone dizzy. But it's really impressive, the kind of recommender systems that they've been able to build. And it's kind of they have an advantage because they have such a rich data set of their users and products. But some companies that are new maybe to the space would like to have personalized recommendation, but they don't have like that treasure trove of data that, let's say, Amazon has, for example. So in this talk, I'll be covering how to create a recommendation system with vector search. But before getting into that, I will start with the impact of recommendation, the traditional algorithms that are used in recommender systems, the new opportunities that you can implement with vector embeddings. I will share a demo and system design. I will say that's the fun part because I'll be rambling a bit, and then I'll show you the demo and sharing it in action. And then I go over the benefits of Ref2Vec, and then I end with a few discussion topics. So Ref2Vec is a feature in Weaviate. It's a work in progress, I'll say. So the discussion topics has a few ways that we can improve it in the future. All right, so starting off with what is the impact of search and recommendation. So Dmitry Kan stated in the Haystack EU keynote talk that nearly $300 billion is lost each year from bad online search experiences. With such a high, why is it? There we go. Sorry about that. With such a high impact, this is an important area to focus on. So 35% of Amazon's revenue comes from their recommendation only, and this was reported in 2013, so quite outdated. So we can only imagine the impact that it has now with the advancements in deep learning and vector embeddings per se. I first want to start off with the definition of recommendation because I often will interchange search and recommendation kind of hand in hand. So start off with the definition from NVIDIA. So recommendation system is a class of machine learning models that use data to help predict, narrow down, and find what people are looking for. Yeah, just like I said, with different companies already implementing recommender systems and having really a personalized experience for you. And then I also want to compare it because I am using search and recommendation. They do go hand in hand, but they are a bit different. Search is query driven, so it's explicit. When you type in Google, you are searching or querying, you know exactly what you're looking for, whereas recommendation is using user preferences and product features to build upon what to recommend to you. So this is more implicit and context driven. So now that I've covered the maybe terminology, I'll go over how do we represent user preferences. So these are the traditional recommendation algorithms that were done in the past. I'll cover this, I'll kind of fly through it. So I'll cover content-based filtering and collaborative filtering. Content-based filtering, what it does is it has it creates genres or product features for each product, and it is, the user is tasked with rating the item. So we know what the user likes, and we can recommend from there. So I'll give a movie example. I don't know if I'm allowed to say pretend you're Netflix, but let's just pretend you're a, I don't know, movie provider. So here I have Elf. I rated it a 6. I have Spider-Man a 4, and The Proposal a 9. So as you could tell, I am a huge fan of comedy and romantic comedy, and I'm okay with superhero movies, but not my favorite. So what we're going to do from there is create a matrix from this. So we have the genres and the columns, and then the movie in the row. So Elf is a comedy, etc. I don't have to list that out. But we're going to multiply that by the rating that I've assigned it. So once I finish the movie, I'm going to multiply that to get my matrix filled with my rating. And then I'm going to divide that by the total to get my weighted genre matrix, which is here on the bottom. Oh no. This clicker is my first time, so probably not the best thing. All right, so here on the bottom we have the rating per genre. So given that, the movie provider, or Netflix, is going to have to take these scores into account because they probably shouldn't recommend superhero movies because I'm just not that into it. All right, so given this, they are debating whether to recommend a few extra movies to me after I've rated the past three. So I have We Are the Millers is a comedy and romantic comedy movie. Then I have Venom as a superhero movie. And then Napoleon Dynamite is a comedy movie. And I think we're all a fan of all of these movies, but let's see kind of what they should recommend to me based off of my past interactions. So given that matrix, we want to multiply it by the weighted genre, which is up above. Given from that, we're going to have the rating per movie based off of the genre that each has. So from there, we're going to take the total of the score for each movie, and this is what they are suggesting to me. So they're kind of in between these three movies on the left-hand side. So given the total, now they are tasked with ranking it. So based off of my previous interactions, We Are the Millers is probably the best movie that they can recommend because it checks the box of being a comedy, a romantic comedy movie, and then Venom at dead last because I'm not a fan of superhero movie. So content-based filtering really takes into account the past interactions that you've made and to suggest new movies to you. Next, collaborative filtering. This is still a traditional recommendation method. So on the rows, we have the users, just U1, U2, U3, and then on the columns, we have the products. So collaborative filtering really uses the wisdom of the crowd, I guess you can say, because it's tasked with finding similar users that are related to you. So just by looking at the matrix, you could see U1 is mixing product 2 and product 4. This could be food, movies, anything you can imagine. And then U2 and U3 have successfully rated each product. So now we want to see what do we want to recommend user 1 based off of their similarity to U2 and U3. Here's my question box. This is the math that we'll go over next. All right, so the easiest way to do this is to use the cosine similarity. So we'll break down the matrix into just U1 to U2 and then U1 to U3. And then notice how we only have product 1 and 3 in the columns because those are all of the product ratings that U2 and U3 gave it. So calculating the cosine similarity from U1 to U2, so seeing how similar these two people are, it is 0.94, which is pretty close, almost 1. You can kind of just see that similarity just by looking at the matrix. Next, you want to do the same thing from U1 to U3, and that is 0.84. So a little bit further, I'm sure if we had more users, we could have more data. So given that rating, we want to put a higher rating to the person that U1 is closest to, which is U2. So on the top, we have 0.94 times 1, which is the rating that U2 gave product to. Then we want to add that to the similarity between U1 and U3 times the score that U3 gave the product. And then you want to divide it by the total to normalize it. Given that, we have 2.4 for product 2, which, we have to kind of see what it will be for product 4 to see what we should recommend user 1. So, like I said, we'll do the same thing for P4. We have 0.94 times 3, which is the rating that U2 assigned for it. Add that to 5, which is the rating that U3 gave to it, and then divide it by the sum to normalize it. Given that, we have 3.9. So, as you can guess, you probably already knew this from just looking at it, but just a quick example, U1 should be recommended product 4 because we assigned a lot of weight to having the similarity between U1 and U2. So there are a few limitations with traditional recommender systems. So scalability is one of the biggest issues. In our example, we had 3 users and then 4 products. But what happens when you scale this out to millions or billions of products and users? That can become very difficult to compute and might have a lot of latency just because it is computational heavy. So it's not really the best approach. Next is user item interaction data is sparse or can be sparse. So in the movie example, I assigned ratings to the past 3 movies that I watched. But what happens if I just enjoyed the movie but forgot to rate it? The provider isn't really going to know this, and that can dampen that can affect the recommendation results. Next is a cold start problem. I know we're all familiar with this, but this is a case for users and products because if you have new users entering your site, you don't really know what kind of movie genres or maybe products that they're interested in. So this is a huge problem for e-commerce companies and also content providers. And also with products, this is a big issue because if it's a movie and you think it falls under superhero, maybe it might fall under comedy, and someone that enjoys comedy might enjoy that as well. So it's really important to have the proper genre assigned to each product. And then, so the last thing is lack of diversity in results. This kind of ties in to the cold start problem. So obviously I'm a fan of romantic comedy movie, but if I am interested in watching, I feel like Deadpool is a good example. So Deadpool is kind of known as a superhero movie, but it's also comedy driven. So I feel like if we forget to assign that it's under the comedy genre, then it might not be recommended to me. And there's kind of like that disconnect there between the provider and user. Okay, that's the traditional way. Now forget it. I kind of breeze through that, but let's get into the vector representations and how you can do this. Clip is a Clip is a popular embeddings model made by OpenAI, and what it does is it is encoding the text and image together. It's like speaking the same language. So we have the description of this dress on the top. We're going to pass that through the text encoder, and it's going to output this vector. We do the same thing for the dress, pass it through the image encoder, and it's going to output this vector. And as you can see, it's pretty similar, and that's because the models are speaking the same language. So if we were to plot this in a 3-dimensional space, you can see that the maxi summer dress, which is the text description, is close to the dress. And this is just a simple 3-dimensional example, but vector embeddings are usually hundreds of dimensions. But for the purpose of visualizing this, I decided to keep it very simple. And then also, also in the case of having different semantic clusters or categories, we have apparel on the right-hand side, and then on the left we have home appliances, and on the bottom we have computer products. So each embedding will be plotted in its respective vector space, and I hope this is visually, you can understand it a bit more, but I'll provide an example of this in a few. All right, so Ref2Vec Centroid. This is the recommendation side of it. I've gone over how you can create these embeddings and how they are plotted in their respective space. But now we have Ref2Vec Centroid, which is a module or feature in Weaviate. All right, so here we have 3 products, a dress, purse, and heels, along with its vectors. Given these 3 vectors, we want to take the average of it. The little jingle is the average to produce my vector embedding. And you might be like, why would you do that? This is because you want to represent my user embedding is a cross-reference to these 3 products, and I am the average of the 3. So 0.7 is the first position in the vector. That is the average of the 3. And instead of having myself represented as an image or a vector, why don't I switch that over with a digital fingerprint? Nice. And I still have my vector, which is an average of the 3 products. Now let's see that in that 3-dimensional graph that I showed earlier. Come on. Here we have it. So my digital fingerprint is an average of the 3 products that I've interacted with so far. So as you can see, the little fingerprint in the middle is right in between the 3 products that I interacted with because it is an average of the 3. Oh my God. Just to summarize it, Wrapup is a way to represent a user embedding by taking an average of the products that they've interacted with. So my digital fingerprint or my user embedding is the one in the center, and then the 3 products on each side is the products that I've maybe added to cart or maybe have interacted with in a positive way. And now is a fun time to get into the demo. All right, so here we have the Weaviate vector store. Very bare bones, but it works and it does the job. So what we have here is the Magento dataset, which contains women's apparel, men's apparel, and then also gym accessories. So here, let's say I'm in the market for leggings. You can see on the bottom the distance to centroid is 0, and that is because my user embedding is basically this only product because I've only interacted with 1 product so far. What happens if maybe I want capri leggings? My user embedding on the top would be somewhere in between these 2. And you can see the distance to centroid is displayed on the bottom. And then we also have, as you scroll down, you can see it gets further away. So usually it's like sweatpants or shorts. I'm not really into shorts. I've so far have only interacted with leggings. So you can see as you go down, it's not relevant to my interactions with the products that I've have interacted with in the beginning. And I won't go over the full way to do this in Weaviate. I'll just provide snippets. So in order to use Weaviate and query your data, you need to create a schema. So here we have the class user, and then we're taking that, we're taking the property and we have liked item. So this is the interactions that these are the products that I'm interacting with. And we're vectorizing that with the liked item to represent my user class. And this is very high level. I will share a GitHub link so you can access it and obviously give it a star in a bit. So that's how the user is represented, but next I want to show the query. All right, so here we're populating the query with the query vector, which is the user. So we are getting products that are near vector, which is an operator in Weaviate, and we are just passing that through to update my embedding in real time. Okay. That was a demo. Next, I will cover, here it is. You can scan this QR code if you would like to access the GitHub repository, and then also give it a star. If you don't have your mobile device, you can also go to Weaviate, and then it is the Wrapup e-commerce demo repository. All right, now that I shared the demo and what Wrapup is, sorry, I'll go back. I think I see a few phones. I want to go over the client-server architecture now. So the client is interacting with items, and we're going to send that to the Weaviate database. So we're sending the user vector, which is the query vector that I just showed, also the liked item, so the products that they're interacting with, and then along with the item vector. And what the database is tasked with is to send the recommendation. And we saw that updating in real time. I interacted with 1 product, and now the personalization of the various products was happening very quickly. All right, so what are the benefits of Wrapup? So there's minimal overhead. Like I said, it's just taking the average of the products that you've interacted with. You're not, it can easily scale, especially because you don't have this large matrix like you have with the traditional techniques. You also offer rapid personalization. So like I said, you interact with one product and it's updating very quickly, which is great because it allows your users to feel at home very quickly, which I think that's kind of good because then you can recommend products fast and maybe make more money that way, or just offer different content in that aspect. And then, like I said, it has real-time updates because it is not compute heavy and it's very fast, which is great, and the benefit of vector search. And I also want to touch on the cold start problem. So like if a user is interacting with a product, it's able to update very quickly, and you don't really face that cold start problem that is seen in the traditional techniques. All right, so the discussion topics that I wanted to touch on, because it's in progress. This is definitely something that we can improve, and I'm obviously looking forward to it and to hearing your feedback on ways that we can do this. So the three things that I want to touch on is ranking models, diversity in results, and then also having multiple user embeddings. This is a common analogy that we use when we're talking about ranking models in Weaviate. So here we have a fisherman that wants to catch this green salmon. He's going out on the boat and he has like a sense of where the fishes are, but he's going to throw this net in order to catch the fish, and probably along with other fishes that are in the vicinity of the net. So they catch the fish in this net, and now they're sorting it one by one to find the green fish. So the net can be seen as retrieving relevant documents. Then you are sorting through each fish to find the green one. And that's really what ranking models are. It's improving your search results. Next is diversity in results. So let's say I've added red and green heels to my cart. I don't want to be recommended yellow heels just because it's what red and green make. I instead want like a complete outfit. So maybe recommend a purse that matches the heels, or dresses that would look nice with it. Because if you recommend just heels in different colors to your users, they will be put to sleep and leave your website. Next is, this is also extremely important, is multiple user embeddings. So in the example that I provided, I was only interacting with apparel. But what happens in the case where I'm interacting with home appliances or computer products? I should have separate embeddings for each vector space. And that's something that I think is very important, because if I was just an average of all these products on this graph, it wouldn't really fully capture what I'm interested in, because it's not representative of what I have interacted with. All right, so the key takeaways I hope you've gained from this talk is you no longer need a treasure trove of data to build a recommender system. Vector embeddings allow you to scale to millions or billions of products and users. And then Ref2Vec offers rapid personalization for your users and has a low overhead. And then on the right, we have Oprah handing out recommender systems. So I hope to see you guys implementing this. And if you have any questions in a bit, I would gladly answer them if I can. And then these are a few resources that I used throughout my talk. You can connect with us by going to weaviate.io. Also check us out on GitHub. And then also we have a Twitter account and a Slack where we answer community questions and just interact with our community. Little more information about me. I think you guys won't forget that my name is Erika Cardenas at this point. And thank you.
Erika, thank you so much. So, do we have any questions for Erika on her talk just now? Okay.
Good talk, great stuff. I mean, it's a very interesting implementation and product. how does it handle, or does it handle, like negative recommendations? Like they disliked a thing, and so you want to move their centroid further away from that vector. How would that work?
Yeah, that's a good point. Thank you for your question first. So in Weaviate, we have a move away or move to that you can embed in your query. And I do think that's very important. In my demo, I kind of just have it as like a positive. So I clicked on the product and now it's adding it and updating my vector embedding. But I do think that's important. Maybe if your website has like a thumbs up, thumbs down, if it gives you a thumbs down, maybe it's like, okay, move away from that kind of product or category of products. So I think that'd be the best way. And yeah, like I said, we're still building on Wrapup, but thank you for your question.
Thank you. So one of those, this isn't so much a question as a comment moments, but from online, but I think you'll like this one. John Underwood says, that was so comprehensive, I can't think of any questions.
Oh, I'm
nice.
flattered. Thank you, John.
Thank you, John. We had a couple of other hands up here. Doug, let me see if I can.
Thanks. That was a delightful talk. Can you talk about how you serialize the ref2vec information so that a user can pick it up in a later session, or over time build a more complete picture of the users using the ref2vec idea?
Of course. Thank you for your question. So in the schema that I showed, the cross-reference and how it's vectorizing it by the products that the user liked, we also had session ID. So I'm assuming we can have multiple sessions for one user. So we're not forgetting their past interactions and just focusing on the newest one, because, yeah, that might completely dismiss what they've liked in the past. So I didn't cover that, but thank you.
Okay. We had one more hand up here, I think. There we go, Tito.
First, I want to give you kudos for raising the bar on visual, a very visual presentation. It was exceedingly clear for a very technical topic. So first that. Second is, I think the model is based on interaction with products. And in an e-commerce context, there's a lot of different types of interactions. So there's browsing, there's like saving, there's actually purchasing. And I'm wondering whether the tool is adaptable to be able to put different weights based on the type of interaction. Because I would imagine if I'll probably browse a lot. So like if you're developing the centroid based on browsing, it's going to take into account a lot of factors, but then I end up buying something. To me, that seems like it would carry more weight. So I'm wondering how the interaction model can be configured.
Thank you for your question. Yeah, I guess there's multiple steps to that. Yeah, so this was just kind of like the positive interaction of interacting with the product, but I think in application, it's important to have separate weights for maybe loving a product, hearting a product, adding it to cart, saving it for later. There's like various things that we can implement, especially in e-commerce. So I'd be curious to see that in production. And there definitely is a way to do that, and having these various weights for these different kind of interactions. Also, something that I've learned while being here was having different dashboards. So maybe we can also add in like how long was the user on the item for, and assigning different weights for that. I think that would be very interesting. Just maybe they got busy and they still have the product up and they're interested in it and they're saving it for later in their head without clicking the save for later button. So having like these different metrics to track, I think is very important.
Thank you. So we have a question online from Matt Corkum. Is there a one-to-many ref vectors per user? How do you know when to retire a vector? Time decay or involve the user, something else?
Interesting. I didn't think about that. I feel like we're, in this implementation, we're actively just building upon the embedding, but I do think it's important to take into account maybe caching, like 3 months or maybe even a month before, because I don't know if people are still like lingering about our product after a year. So it maybe depends on the application, I would say. And thank you for the question.
Great. John.
So one quick follow-up. Amazon does really well with their collaborative filtering, but there are times when I may click on something only once, and then I get a bunch of movies related to that that I'm not interested in. They have a UI where you can update what you've viewed, and you can delete it, remove it out of the process. Can you do something like that for the consumer to sort of have more active control?
Thank you for your question and or comment. But I think that's important, obviously, to have more control, especially if you maybe accidentally interact with a product. You shouldn't necessarily be hounded down to buy this product now at this point, but not in the current state, I believe. But let me think about that one. Sorry. All good points. Thank you, everyone.
Fantastic. Do we have any more questions from the room? Carl.
Actually, I think my question is quite related to the negatives, and that's sort of like if somebody's actually gone and bought a product, you definitely want to take that into account when you're building out their embedding. But they, depending on what it is, they probably don't want to buy it again. So you probably want to avoid recommending the same car that they just bought, sort of thing, right? So I was wondering if there's any kind of provision for that.
That's in the discussion topics of the importance of having a diversity in results. Like I said, you shouldn't be recommended the same heel in a different color. It should instead suggest a complementing dress or purse for you. So not in the current state, but that is very important, and I agree.
We have one more. How am I going to get over there? Thank you.
This isn't too far off from filtering out a specific product, but I'm curious about filtering on item-to-item relationships on particular dimensions. The use case that comes to mind is if you're shopping for car parts, there's a very clear Boolean of this either will or will not be compatible with these other parts that I've purchased, right? Is there any tooling that would enable that, or is it just a matter of making sure that your embeddings have a dimension that reflects that and that sends a very strong signal?
Thank you for your question. Also, in Weaviate, we have filters that are optional. So in the demo, we didn't include it, but in maybe like the first provision, we had price. So we had like to scale. You can say, I'm interested in leggings that are this certain price range. But yeah, I hope that answers your question. You can filter as well.
Okay.